Hello everyone. Let's take a look at two more examples for verifying trig identities. The first example, my left-hand side, cosine squared of x minus sine squared of x, and that is equal to this fraction, cotangent of x minus the tangent of x, divided by tangent of x plus cotangent of x. So, as usual, one of the good strategies is to work with the more complicated side, which is going to be the fraction in this case, especially because my left-hand side here is just sines and cosines. So let's see if we can take this right-hand side and transform it into an expression that matches the left-hand side. I'm going to start by rewriting all of this in terms of sine and cosine. Just looking at this to begin with, we don't have anything that's squared, so I don't know if the Pythagorean identities are going to help right now. And multiplying by the conjugate isn't going to make anything simplify here either. So I think the best approach, we'll just rewrite everything in terms of sine and cosine, and then we're going to have to combine some fractions together, but then we should be able to start simplifying. So our left-hand side, this will stay the same. And then our right-hand side, so cotangent is cosine over sine, and tangent is sine over cosine. So we are going to see here that our numerator and our denominator, they're pretty similar to each other, but with the one difference that one's plus and one's minus. So there's not any, we can't factor or simplify anything yet, but so in the denominator we have the sine of x, cosine of x, and then cotangent is cosine over sine. Okay, complex fraction again, and we've seen this a couple times now, but when I have a complex fraction, one way that we can work with this is we can combine our two terms in the numerator, combine the terms in the denominator, so that we end up with one fraction divided by another fraction. And then once we have that, we can turn that into multiplying by the reciprocal. So let's combine these together. To do that, we do need a common denominator. So my right-hand side here, this will be the same. So common denominator is going to be sine times cosine. So for this first fraction, we need to multiply top and bottom by cosine. So we're going to end up with cosine squared over sine and cosine. In the second fraction, we need to multiply by sine on top and bottom. So we end up with sine squared divided by sine cosine. And we have to do the same thing in the denominator. So this first one, top and bottom by sine. So the sine squared of x, and then the sine and cosine, and then plus, multiply top and bottom in this one by cosine. So then cosine squared over sine and cosine. Alright, so now we can combine our numerator and denominator together. So in the numerator, subtracting, we have cosine squared of x minus sine squared of x over our common denominator. And then in the denominator, we have sine squared plus cosine squared over that common denominator. So this is just one way to handle that complex fraction, but now we have one fraction in the numerator, one fraction in the denominator, and we can change this into multiplying by the reciprocal. So cosine squared of x minus sine squared and then times, we'll take this bottom fraction, we'll flip that to the reciprocal, so we have sine cosine divided by sine squared of x plus cosine squared of x. So now we have some things that we can simplify. Sine times cosine, sine times cosine. So we have one of those in the numerator and the denominator, so that will simplify to 1. Also, sine squared of x plus cosine squared of x, that should be very familiar. This is your Pythagorean identity, so this entire thing is equal to 1. So that can simplify as well, and all we are left with is our cosine squared of x and sine squared of x. Which is what we're looking for. So it's another example of how rewriting in terms of sine and cosine, and then just having to simplify this complex fraction leads us to where we want. All right, let's try one more. So here we have the sine of theta divided by 1 minus cotangent plus the cosine of theta divided by 1 minus tangent. And that is equal to sine of theta plus cosine of theta. So the right-hand side is definitely the simpler of the two. So let's work with our left-hand side to see if we can't transform that into the right-hand side. Alright, I do have a couple options here. I could combine these fractions together, multiply this one by 1 minus tangent, multiply this fraction by 1 minus cotangent, and then I can combine them together and see where we go from there. Since we did this on the last one, I think I'm going to do the same thing here. I'm just going to rewrite everything in terms of sine and cosine, and then work with these fractions a little bit. So the sine of theta, cotangent is cosine divided by sine. And then in the second one we have cosine. And then rewriting the tangent, we have sine over cosine. And then our right-hand side is staying exactly the same. Okay, let's combine these terms together for both these fractions. So to do that, we need a common denominator. And we've seen this a couple times now, but I'm just going to turn this 1 into sine over sine. So let me just write that all out. So the sine of theta, then we have the sine over sine, so that's our 1 minus cosine over sine. So then we can combine those two together. Do the same thing with the second fraction. So instead of 1, because our denominator is cosine, we'll do cosine of theta over itself, and then minus sine over cosine. So now for both these fractions, let's combine these two terms together. So here we're going to end up with sine minus cosine over sine. And then in our second one, we have our numerator, and we end up with cosine minus sine. And that's over cosine. So now with both of these, combining those terms in the denominator, we're dividing by a fraction. So we can turn that into multiplying by the reciprocal. So we end up with sine of theta times, and then if we flip that fraction, we end up with the sine of theta over sine minus cosine. And then in the second one, we have the cosine, and then flipping that fraction, we have cosine over cosine minus sine. So this is like it's over 1. Same thing with our cosine. So then multiplying these fractions together, we multiply the numerators. multiply the denominators. So that's going to be sine squared of theta over sine minus cosine. And then in the second one we have cosine squared over cosine minus sine. Okay. I still want to combine these fractions together, but my denominators don't quite match up. This is positive sine, negative cosine. My second denominator is positive cosine, negative sine. But a really easy way to get these to match is I can just factor out the negative 1 from this second fraction. If I factor out a negative 1 here, this will switch both of these signs, and I'll end up with a negative cosine, a positive sine, and then this cosine squared up top will just be negative. So factoring out the negative 1 will give us that common denominator. So cosine theta, this will turn into minus cosine squared, and then our two signs switch here. So now we can combine these together, and we end up with sine squared of theta minus cosine squared over sine minus cosine. So we're almost there. Sine squared minus cosine squared, that's not the Pythagorean identity, but we can actually factor this. This is the difference of perfect squares, so this can factor into 1 plus and 1 minus. So sine plus cosine and sine minus cosine, which is good because if you look at the denominator, our denominator matches with one of those factors. So sine minus cosine, that will simplify with the sine minus cosine in the denominator, and we are left with sine of theta plus cosine of theta, which is what we were looking for. So again, to recap, my right-hand side here, this stayed the same the entire way through. All we're doing is taking the left-hand side, this expression, and we are working with that until we get to a point where that matches the right-hand side. So if I want to justify this, I could say that by the transitive property, the sine of theta divided by 1 minus cotangent of theta plus cosine of theta divided by 1 minus tangent theta, by the transitive property, I know that is the same following this series of steps. I know that's the same as sine plus cosine.